we're asked to simplify the principal square root of negative 52. And we're going to assume, because we have a negative 52 here inside of the radical, that this is the principal branch of the complex square root function, that we can actually input negative numbers in the domain of this function, that we can actually get imaginary or complex results. So we can rewrite negative 52 as negative 1 times 52. So this can be rewritten as the principal square root of negative 1 times negative 1 times 52. And then, if we assume that this is the principal branch of the complex square root function, we can rewrite this. This is going to be equal to the square root of negative 1 times the principal square root of negative 1 times the principal square root of 52. Now, I want to be very, very clear here. You can do what we just did. If we have the principal square root of the product of two things, we can rewrite that as the principal square root of each, and then we take the product. But you can only do this, or I should say, you can only do this if either both of these numbers are positive or only one of them is negative. You cannot do this if both of these were negative. For example, you could not do this. You could not say the square root of, or the principal square root of 52 is equal to negative 1 times negative 52. You could do this so far. I haven't said anything wrong. 52 is definitely negative 1 times negative 52. But then, since these are both negative, you cannot then say that this is equal to the square root of negative 1 times the square root of negative 52. In fact, I invite you to continue on this train of reasoning. You're going to get a nonsensical answer. This is not okay. This is not okay. You cannot do this right over here. And the reason why you cannot do this is that this property does not work when both of these numbers are negative. Now, with that said, we can do it if only one of them are negative or both of them are positive, obviously. Now, the principal square root of negative 1, if we're talking about the principal branch of the complex square root function, is I. So this right over here does simplify to I. And then let's think if we can simplify the square root of 52 any. And to do that, we can think about its prime factorization, see if we have any perfect squares sitting in there. So 52 is 2 times 26, and 26 is 2 times 13. So we have 2 times 2 there, or 4 there, which is a perfect square. So we can rewrite this as equal to, well, we have our I now. The principal square root of negative 1 is I. The other square root of negative 1 is negative I. But the principal square root of negative 1 is I. And then we're going to multiply that times the square root of 4 times 13. 4 times 13. And this is equal to, going to be equal to I times the square root of 4. I times the square root of 4, or the principal square root of 4, times the principal square root of 13. The principal square root of 4 is 2. So this all simplifies, and we can switch the order over here. This is equal to 2 times the square root of 13, 2 times the principal square root of 13, I should say, times I. And I just switched around the order. It makes it a little bit easier to read if I put the I after the numbers over here. But I'm just multiplying I times 2 times the square root of 13. That's the same thing as multiplying 2 times the principal square root of 13 times I. And I think this is about as simplified as we can get here.